Hello. So for today, we'll talk about thermoregulation. How will the body regulate our own body temperature? This will be our basic outline. So to start off, we have three types of heat loss: radiation, conduction, and evaporation. If you will observe this man with minimal clothing at room temperature, roughly around 25 degrees Celsius, majority of body heat is lost to the environment as infrared heat waves. So that's around 60% of our body heat. Now, all objects will emit some form of infrared heat. A second type of heat loss is via conduction. So if you will observe the man again, seated, around 3% of his body heat will be conducted to the seat. Now, a special type of conduction is called convection, wherein body heat is directly transferred to the air or water molecules that surround our body. Now, since heat increases the random motion of molecules, as heat is being transferred to the water or air molecules that surround our body, they gradually move away from our body and immediately they are replaced by a new set of molecules. So this is called convection. That is why when we fan ourselves during hot weather, we feel a little bit cooler. Now, at room temperature, evaporation accounts for around 22% of heat loss. So it is said that around 0.56 kilocalories per gram of water is lost via evaporation. Now, under room temperature, this is your insensible heat loss. So we lose around 16 to 19 kilocalories per hour. Now, when we sweat at higher room temperatures, evaporation is increased. So, if our skin temperature is greater than environmental temperatures, heat loss is mainly via radiation and convection. However, if skin temperature is much, much cooler than environmental temperature, meaning the environment is too hot, heat loss is mainly via evaporation, most especially via sweat. Now, should skin temperature equal environmental temperature, there is no loss or gain of heat. Now, clothes will increase the private zone of air that surround our body, minimizing air convection. Now, the type of material is important in order to preserve heat loss. So, if you will observe Arctic clothing, the type of material further decreases conduction and convection and increases the private zone of air that surrounds our body, thus minimizing heat loss. Now, when clothes become wet, heat loss is greatly increased because water has a high specific heat. This means that you need high amounts of heat or energy in order to increase the temperature of water. Thus, wet clothes will increase conductivity by around 20 times, thus increasing now heat loss. Now, talking about body temperature, we have two types: core temperature and skin temperature. Now, core temperature is being generated by the different visceral organs and the skeletal muscles of our body. Now, this is roughly around 36 to 37.5 degrees Celsius, and clinically, this is observed or measured via oral or rectal readings. Now, We have seen thermal scanners or thermal guns that detect temperature of the tympanic membrane. So this is reflective of core temperature. Skin temperature, however, changes with the environmental temperature. So this will reflect the body's ability to lose or gain heat, such that if heat production is greater than heat loss, then body temperature will increase, but when heat production is less than heat loss, then body temperature decreases. Now, talking about heat production, we've mentioned that the internal organs and the skeletal muscles generate heat for our body. So this is due to the chemical activity of cells, thus resulting to basal metabolic rate. Now, our basal metabolic rate is basically regulated by various hormones and neurotransmitters. Now, another mode of heat production is via food. So this is called the thermogenic effect of food. So when we eat, digestion basically produces heat. Now, heat being produced within the deep organs of our body has to be conducted to the skin in order for the body to lose heat. Now, the conduction of heat from core to skin is basically regulated by two important mechanisms. First, we have the insulator system, and the second would be blood flow going to the skin. So from there, heat from the innermost parts of our body is conducted to the skin, and then from the skin, it is transferred to the environment via radiation, conduction, convection, or evaporation. So here we have the two systems that will regulate heat transfer from the core to the skin. So first you have your insulator system. This is basically subserved by the skin, subcutaneous tissue, and adipose tissue, and they maintain now core temperature. Fats is said to conduct heat by only about 33% as readily as compared to other tissues. Now looking at blood flow to the skin, here you have your arteriovenous anastomosis. Now notice that when we are exposed to warmer temperatures, blood vessels are dilated, so blood flow going to the skin is increased. So that will conduct more blood going to the skin, so core temperature is conducted to the skin and heat is lost to the environment more readily. However, when we are exposed to cooler temperatures, arteries in the cutaneous vessels will constrict. So this will decrease blood flow going to the skin. Now, blood is shunted via the arteriovenous anastomosis going to your venous plexuses. Now, since blood is decreased in the skin, less heat is conducted going to the skin than out into the environment. So it is said that when we are exposed to colder temperatures, 0% of our cardiac output goes to the skin, and cardiac output going to the skin increases as we are exposed to warmer temperatures.